All right, Castro, read number 1.
A particle moves along the x-axis so that its velocity at any time t is greater than or equal to 0 is given by v of t equals negative 4t squared plus 10t minus 10.
Part A.
What direction is the particle moving at t equals 2? Explain.
So what direction is a particle moving? Now it's moving along the x and y axis. So it's either going to be left or it's going to be the right. And let's go to our PVA card. The particle is going to go to the right when the velocity is what? Positive. It's going to go to the left when the velocity is negative. Isn't that the velocity function? It's not the particle. So if you want to go ahead and be consistent, write f prime just like on the card, go for it. You don't have to. So let's go ahead and plug in t equals 2 into our velocity function. V of 2 is equal to. So we have negative 4 times the 2 squared plus 10 times 2 minus 10. And when I do the math, the first one is going to give us negative what? 16. And then the second one is going to give us plus 20. Is that right? And then we have minus 10. Where are we? So our final answer will be negative 6. So it says our velocity is negative. So are we going left or right? Left. So let's write left. And that is because V of 2 is negative. And again, my pen is slowly dying. I don't know how that's possible. Every single time. Okay, let me change this. Okay, is everyone good with this? All right. The next one. Kenneth, let's read part B. Okay, so I'm going to go to my last card that we made yesterday. The speed is increasing when the velocity and acceleration has the same sign. It is decreasing in what case? When they have opposite signs. So right now we know the velocity is already negative. So at this point we know our velocity is negative. But I need to figure out what about the acceleration? And we know the acceleration is a derivative of the velocity. So I need to go to my velocity function, find the derivative of it. So what is the derivative of this function right here? Negative 8t plus 10. And it says at t equals 2, let's plug in the 2 into that new function. So we have negative 8 times 2 plus a 10. And just kind of coincidentally, we get the same value, right? Negative how many? So we know the acceleration is also negative. Oh, thank you. So when I have the same sign, what is happening to my speed? Increasing. So let's write out. It is increasing. And again, we have to explain. It is because V of 2 and not V. I can make that into an A, right? A of 2. What kind of sign do they have? Same sign. Can y'all see my green pen okay? I don't think there's a big contrast. All right. Any questions on that one? All right. For my second one, Luke, read.
Table below gives a value for the velocity in kilometers per second of a particle moving along the x-axis for selected values of time t in second. Velocity is a differentiable function of time t. Use the data in the table to answer the following questions.
All right, so notice our given table is our velocity, not the particle or the position. So if I were to find the slope of the velocity, are we getting the position or the acceleration? The slope, the derivative of the velocity is acceleration. Just kind of heads up on that. So on part A, Dylan, read. So if I'm looking for the average acceleration, I'm looking for a rock. And they gave us 2 intervals. So one of them is at 0. I think I'm going to go ahead and circle this. And then we have it at 4. Is that right? So let's write our slope equation. It is v of 4 minus v of 0 over 4 minus 0. Then I'm going to plug in what are the actual values of a numerator. So we get 6 minus 2 over 4. How many would that give me? 1. And we're looking at 1. Our units will be kilometers per second what? Squared. That's it. It says to show, it didn't say to explain. If it were to have said explain, then you would just say that in words. The acceleration of blah, blah, blah. Any questions on this one? All right. For part B, Maddie, let's read.
Is there guaranteed to be a time of 0 less than or equal to t less than or equal to 8 when a of t, the acceleration at time t is equal to 0? Explain.
So they're telling us we have the acceleration at time t is going to be at 0. So a of t is going to be 0. So that's our derivative. So if they're asking us, when is my slope 0, we would have to go to our function. See if I have a different color. Pink might work. So if I need to do y2 minus y1 and make it a 0, they have to be the same number, correct? Where do I have the same numbers on the y values? At 2 and 6. So let's go ahead and apply that. First, let's go ahead and say, is there a time? We should answer that part, yes. What theorem are we going to use if I'm letting the derivative equal to the average? If y'all remember. MVT, thank you. So we know we're going to use mean value theorem. So I have to list a condition on the mean value theorem. V of t is continuous and what else? Differentiable on the interval given initially, which is 0 to 8. And then I could go ahead and set the slope equal to that number. So in this case, our two numbers that we chose were at 2 and 6. So we have v of 6 minus v of 2 over 6 minus 2. And that number is going to give me 3 minus 3, and it should be the same. Otherwise, it won't be 0. So we have 0 kilometers per second squared. So I'm going to go ahead and defend this by our definition, by the mean value theorem. At a of t must be 0 on the interval we chose was from 2 to 6. And that is good to go. So the interval within has to be always smaller or the same as the general interval notation. Okay? Did y'all realize every time there was a word guarantee, we've been using the MVT? Did y'all realize that pattern? Okay? If you didn't, I want you to notice that now. All right? Our last one says, is there a time when the particle is at rest? So yesterday I mentioned the particle is at rest when the velocity is equal to what? Is equal to 0. And don't we already have the velocity function anyways? So I'm going to go to my y values and see where I could plug in the 0. So it's continuous, and I know it's got to go right here. So I could say yes. And if we're looking at 0 is between 3 and -1, what theorem is that called? IVT. So we know -1 is less than 0, less than 3. And with our notation, we have v of 8 is less than 0, less than v of 6. And that is by intermediate value theorem. Our particle is at rest at v of t equal to 0 on the interval that we got was 6 to 8. All right, last page. Are we all good? You can flip it over. All right. Now, number 3 is something that we've already done from the packet. Does that look familiar? Yes? And I kind of warned you yesterday that you're going to see one like it. So on number 3, Addison, let's read the instruction.
Of the particle along the x-axis is 0 is less than or equal to 2, which is less than or equal to 8. Use the graph to answer the question.
Okay, so the graph is not the position, it is a velocity. So let's go ahead and list everything about the velocity first. So any value above the x-axis is positive or negative? positive. So V is positive here, V is positive. And any value below the x-axis must be, so V is negative here. And I know V is negative over here too. If you want to just write that once, that's okay. And then let's list out, what about the acceleration? The acceleration is the slope. From left to right, is my slope going up or down? It is going up, so A is positive. From left to right, is my slope going up or down right here? Down. It is down over here and continues to go down right here. What can I write about the slope of this flat line if you wanted to? 0. We might or might not need that piece, and that's okay. All right? So part A. Hannah, let's read part A. So particle is moving. Oh, this pen is out. Particle is moving to the left. So if your PVA is still helpful, the particle is moving to the left when the velocity has what kind of sign? Negative. So where do I have my negatives? All that? So we know 5 to, is it 5 to 8? I see 5 to 9. And that is because V of t is what? Is negative. Don't tell me V of t is decreasing. It's physically negative as the value. All right. Let's see. Emily, let's read part B. So at t equals 4 is right here. And that happens to be when the velocity and the acceleration, they have what kind of sign? Opposite sign. So I could go ahead and say it is doing what? It is decreasing. And let's write the reasoning. Because the velocity, V of t, and A of t has what kind of sign? Has opposite sign. What if you were to say one is positive and one's negative? Is that sufficient? For sure. That's still full credit. All right, part C. Karis, let's read. So speed is increasing when the velocity and acceleration has what kind of relationship? Same. How many of the same locations do I have? 0 to 3. Do I have another one? 5 to 6. It's very narrow. So let's write out 0 to 3, union 5 to 6. And that is because what's happening to the signs? So A of t and B of t, they have the sign. That's the same as sign together. Weird sign. Bless you. All right. Part D is saying, what is the acceleration? Now keep in mind, the graph that I gave you is not the acceleration graph. So we have to find out what is the slope of the velocity. Since the graph is given, we can use rise over run. So let's go to 5. At this point right here, isn't that part of this linear function right here? So do your rise over run. Hopefully you'll get some negative number. I think it's pretty steep. -6? Is that right? Very well. Good. That's it. All right. Any questions on these 4 so far?
No.
Good. All right. So on number 4. Graham, let's read number 4.
A particle moves along the x-axis anytime t is greater than or equal to 0. Its position.
Okay, let's first look at the condition. We're looking at the condition where we have all the t value must be greater than or equal to 0. Particle is at rest when the velocity is what? 0. And we know the velocity is a derivative of that. So I'm going to go ahead and find the derivative. Maybe I could put equal to x prime of x or t. To find the derivative, we're going to get 3t squared minus 6t minus 9 and set that equal to 0. And while I'm at it, let's factor out the 3 because I don't need it. So So I have t squared minus 2t, the minus 3. And when I do factor this, what two numbers will satisfy the product of negative 3 and sum of negative 2? Negative 3 and 1, very good. And if I set the first one equal to 0 and second one equal to 0, our critical points that we have are going to be positive 3 and negative 1. Which number can I not include? The negative, because it's not within the domain. So what would be our answer then?
Yeah,